Hey everyone, welcome to STEM Time with Navya and Aishwarya. We are your hosts, Navya.
And Aishwarya. Our topic today is about abstraction. And we're really excited to talk about it. But before we dive in, as we promised, we're going to give you a quick update on the current event.
So, a summary of this current event is that researchers have found a new way to speed up quantum computing using giant atomic ions that could pave the way for huge leaps forward in computer processing power.
Wow, that's amazing. So let's dive right in. What is abstraction? Well, to put it in the most simple terms, abstraction in programming is just a simplified version of something more complex. And the goal of abstraction is to simplify a process by removing unnecessary information. So to help you understand better, I'm going to give you a few examples. For example, when you see a state map and you only see city names, you can tell uh, that there is abstraction because it is a simplified map. Every state has roads and rivers, but on the specific map you're looking at, there's only cities mentioned. Therefore, it's an example of abstraction.
Another example is in a phone, we only use the volume controller, the power off button, and the home button, but that is just for the interfaces. We users only interact with a simple interface with a few controls, but there's a lot more work going on within the phone itself in order for the functions to work as smoothly as we think it does.
And I think it's always important to remember that the easiest way to tell if something is an abstraction is to ask yourself if a complex process has been simplified.
But what are the examples of abstraction in computer science? So there are variables, procedures, and data abstraction. So for variables, rather than having large numerical values and its computations, we can define them as variables. Then another example is procedure. So if I want to draw a square multiple times, I could use a procedural abstraction in which I would execute the command of draw square 3 or 4 times instead of saying draw line 12 or 16 times. And so another example is data abstraction, where everything in a computer is represented as bits, which are the digits 0 or 1.
Great. So before we move on, I think it's really important that we not only understand what abstraction is, but also the applications of abstraction. So abstraction is really helpful, especially to programmers, because when they use a simplified version of something, it makes it easier in multiple aspects. The methods are easier and the program runs more efficiently because a complex situation has been simplified. And abstraction is one of the major concepts of languages in object-oriented programming. But now we're going to talk about what data abstraction consists of and what the levels are. And I think Geeks for Geeks was an amazing website to help give examples that were easy to understand. So let's dive right in and talk about the three main levels of data abstraction, which are physical, logical, and view.
So physical, also known as internal, is the lowest level of data abstraction, and it tells us how data is actually stored in memory. So the usability, amount of memory, and the blocks of storage all play a big role in the step of the process. Then the next one is conceptual or logical, and this is the level that actually stores the data through tables, and it is mostly known for storing the relationship among data entities and through simple structures, as quoted by Geeks for Geeks. And then also external or a view is the highest level of abstraction, and it is the part that is actually viewed by the users. This level does its best to be user friendly, and users can view the data in rows and columns, but storage and implementation details are hidden from them.
So, how exactly can we put these steps together to make abstraction? We're going to talk about the steps in order to make them. And 101computing.net provides an excellent set of steps to follow and efficiently make an algorithm. So our first step of the process is to define the problem. If you don't have a problem, you can't really have a solution.
So, for example, the problem that we'll be using while explaining these steps will be the question, how can we create a computer program used in the Google car to inform the passengers on the directions for their journey, as well as the factual information such as the duration of their journey and the estimated mileage?
Great. So after we identify the problem and define it, we need to identify the inputs and outputs.
So in this particular example, what would our inputs be? Well, the inputs would be the where we are currently, which is our origin, and then the destination where we want to go. Then what would the outputs be? What do we want from this information? We want to know the distance between the origin and destination. We want to know how long it will take or the duration, and also how to get there or the directions.
So after we have done that, we need to identify what the problem's components are. So the breakdown is steps in order to achieve your goal.
So, what exactly do we need to go through in order to to output the things that we need? So, first we need to find the shortest route. So, this would be the most efficient way to get to your destination. Then you need to calculate the distance in order to output that, then calculate the duration, and then also display the directions.
Also, before we actually start to put things together, this next step is a little longer than the other ones because you have to plan for code reusability. So you have to plan to reuse the code using existing libraries. You also need to define functions and procedures and use object-oriented concepts like classes and objects.
So, like Aishwarya said, make sure you import libraries, define functions and procedures, and use object-oriented programming concepts such as class or objects, and these are extremely important to get you started on programming.
Great. And now we can finally move on to our last step. So our last step is to define and design programming algorithms.
So this is a throwback to our previous episode about the algorithms, and so please go check that out if you haven't already. But remember, use the three main building blocks that we discussed earlier: sequencing, selection, and iteration.
So that's it for today about abstraction and data structures. And I hope you guys had a wonderful time listening to this podcast. So don't forget to tune in to our upcoming podcast. Feel free to reach out through our Instagram and Twitter page at STEM Time Podcast. Don't forget to keep learning new things. See you in the next episode. Bye.
Bye!